Okay, this video will cover distributed load. Distributed loads are unlike point force that they apply to one point. They apply over the area in 3D or over a line in 2D. Now, many pointed that we are encountering on a daily basis, they are point force. If I apply force like this, if you press your foot on the gas on your car, that's a distributed load. It's not a point force. It's applied over the area. Now, in this case, we are talking in 2D, distributed load, it's going to be the units of it is going to be kilonewton over meter, pound over force, or any unit which is force over length. Could be pound per inch or anything similar to that. Now, dealing with distributed load, again, we are talking about two types of it, which is very common. One type is rectangular shape, or we call it uniform loading. You have a base and the height stayed the same. Now, in this case, for instance, you have 100 kilonewton per meter on the height. So you want to convert this to a point force. So this is actually converting from distributed load to a point force. When you convert it to a point force, two things are important. How much and where I have to put it. Because when you answer the question for where, that's very important, because where it's applied, it's gonna have a lot of effect in our moment. In this case, it's a rectangle, so base times height, that will be how much. That's the area of it. And where I put it in the middle. For a triangular shape, we have half of BH, and then we put it on 1/3 of B. So before we go cold, let's solve an example. In this example that I have a distributed load like this. There are two triangles on two sides. Now, what I want to do, I want to find the reaction at A and reaction at C. So, in order to proceed with this problem, I need to replace this two triangular shape with two point force. So, the one on the left, this one, the height of it is 600, the base of it is 3. Again, I'm going to redraw it here. At point A, I have a pin, so I'm going to get AY and AX. And then at point C, I have one force, that will be CY. So for the first triangle, again, triangle on the left, I'm going to have, this is the height of 600, and that's the base of 3. So I'm going to put it in 1/3 from the fat part, right? So down here is the wider part. So 1/3 from here. So it will be somewhere here. The magnitude for this is going to be half of 600 into 3, which is 900 pounds. That was easy. Now the next one, where I put it in 1/3 of 3, which is going to be right here. 1/3 of 3, which is equal to 1 feet down here. The next force, distributed load, is the right one. The one on the right, again, everything will stay the same, except that will be 1/3 from this way, right? So 1/3 of 3, which is going to be 1. And then that's another 900. So what I could do, in order I can find CY, then I can find the sum, all those equations that we did before. The only trick in this side was to convert from distributed load to point force. From there on, we know what to do. So I'm going to say sum of f of x equal to 0. From here, I'm going to get AX is 0. Sum of f of y equal to 0. From here, I'm going to get on the y, I have 900, two 900s, right? Minus 900 minus 900 plus AY plus CY equal to 0. And then sum of moment, I do about point A is equal to 0. Then from there, I have a 900, which is again clockwise, times 2. This distance is 2, by the way, because the other distance was 1, right? So times 2 minus another 900. That distance for that is a 3 here and a 1 there. So it becomes 4 plus cy equal to 0. From here cy is equal to 400, something like this. Yeah, plus 5400. Now once you have cy, you can go back there, and then from here you can find ay. So in this case I have the cy plus ay, bring the 5400 here. So you got minus 1800 plus ay plus cy equal to 0. This will be 5400. Then the answer for that is this is 2 times 9, 4 times 9. The answer ay is minus 3600. Yeah, the unit is pound. Again, it was we were able to solve it. Now I want to use the same concept but make it a little bit more complex, right? So let's do a couple of problems on like using distributed load and the concept of. So let me stop this video for now.